Welcome to this video. We're going to finish off the AP Calc BC 2012 no calculator portion, part of the exam. We are on 21. Okay, so the line y is 5 is a horizontal asymptotic graph of which of the following functions? Okay, so sine 5x over x. This will not have a horizontal asymptote. Y is 5x is a linear line, no horizontal asymptote. This guy, if we did it as a rational function, if we did a degree test, degree of the bottom is bigger. So there's a horizontal asymptote at y is 0, which is not y is 5. Degree test, degrees are the same. Take the ratio of the leading coefficients. It'll be 5 over -1. So our asymptote is y is -5, which is not y is 5. So we're left with this because degree test, degrees are the same. Take the ratio of the leading coefficients, 20 over 4, that's 5, which measures that. Okay, that one's easy. Okay, this one is very conceptual. The power series summation n goes from 0 to infinity, a sub n, x minus 3 to the n power, converges at x is 5, which the following must be true. It asks us if it converges or diverges at different points. Okay, so we have to remember that the power series, it converges, there's a radius of convergence, okay? So there's a center point where the power series is centered at. So if I draw a number line, there's a center. And then there's some radius of convergence. And let's say this is R, and this is R, okay? There's some radius of convergence centered at the center, okay? So if we go to the right, it'll be the length of the radius. Similarly, when we go to the left, it's the length of the radius. Within that region, this region, it's going to converge. At the endpoints, we have to check manually. Remember that process for finding the interval of convergence? We have to check the endpoints to see if it converges or not, okay? So okay, in this particular case, the center of this power series is 3. Okay, so if we draw our line, the center will be 3. Within some radius, it's gonna converge, and 5 is within that radius. Okay, it might be at the endpoint 5. Okay. So let me draw it once more here. So if this is 3, and if 5 happens to be at the endpoint, okay, then what's our radius of convergence? R is 2, because 5 is 2 away from 3. So at most on this side, it must also be 2. So it would be 1. Okay. But remember, I just said at the endpoints, we don't know. We have to check manually if it's convergent or not there. So what happens if it's like this? Or it could be like this. We don't know. So at x is 1, we don't know which one. So, because it asks us must be true. 0 is outside our radius, so cannot be that. 6 is also outside the radius, so must be true, must be 2, because that's 2 is here, right? That's within the radius of convergence, okay? If it happens to be that 5 was within the radius, not at the end, okay, then 1 would be fine, okay? Because this guy, again, is 2. This guy over here is 2, okay? It's within our radius of convergence. So it would have worked, but this is talking about most general case. So in general, if this is the endpoint, then at the other end, at 1, we don't know whether it converges or not. But everything in between 1 and 3 is fine. So for example, when x is 2, it's totally fine. So that's how we get D here. Okay, so this is a very conceptual question. Hopefully that helps to solve this one. Okay, this one was easy also. P of t is the size of a population at time t, which the following differential equation describes linear growth in the size of the population. So if P is growing linearly, they're asking about derivative of p with respect to time. What's the derivative of a linear thing? It's just a constant. This is p prime, or dp dt. So which one of these is a constant? It's A. Just easy points. Let f be a differentiable function such that f of x sine x dx, the integral of that, is negative f of x cosine x plus integral 4x cubed cosine x dx, which the following could be f of x. This should look like integration by parts. Hopefully you're able to recognize that. Okay, so remember what integration by parts is. It's u dv is uv minus integral v du. Okay, so which ones are u, which ones are v in here? Okay, and from here. So if we okay, so f didn't change, right? So that must be our u, because it's u here, it's u here. If dv was f, we would have the antiderivative of f in this term, which we don't have. We still have f. So u must be f of x. So du would be f prime of x dx. dv would be sine x dx. V is negative cosine x, right? Okay, so we probably don't want to use this term to help us find what f is. This guy, though, this is minus integral v du. So if we take it from here, minus integral v du, that would be minus negative integral cosine x f prime of x dx. Okay, this must be equal to this guy, 4x cubed cosine x dx. Okay, two negatives, we can just make it positive to make our lives easier. Okay, now cosine x dx is there, so f prime of x must be 4x cubed. So what is f? It'll be x to the fourth plus some constant c, right? So what should the function could be a f? So this is the only x to the fourth, right? In this case, c is 0. Okay, so the answer is E. So this one's integration by parts. Okay, we have this improper integral. How do we solve this? If it was not an improper integral, it's a normal integral, how do we solve it? Hopefully you can see we can do it. Substitution. So if we let u be negative x squared, du would be negative 2x dx. So we can rewrite our integral as, let's worry about limits in a bit, x dx would be du over negative 2, so negative half du. E to negative x squared is just e to du. Okay. Limits of integration, when x is 1, u is, we plug into here, right? It'll be negative 1. When x approaches infinity, what does u approach? It'll be negative infinity. Okay. We can flip the limits and put a negative sign out in front. There's already a negative there, so it'll become positive half integral from negative infinity to negative 1 e to u du. You don't have to do this, but it just looks nicer like this. All right. So when we integrate, we get negative half e to u, evaluate from negative infinity to negative 1, which is half e to the negative 1 power minus 0. So just 1 over 2e. Okay. What is the slope of the line tangent to the polar curve? R is 1 plus 2 sine theta at theta is 0. Okay? So remember, slope of the tangent line as dy dx, which is dy by d theta over dx by d theta. Okay? Similar to parametric equation. Okay? What's dy d theta, dx, and d theta? This is the part that I don't memorize. I just derive it every time. So we remember that x is r cosine theta and y is r sine theta. Okay? So we can even say x is, what's r? It's 1 plus 2 sine theta times cosine theta. Okay? And y is 1 plus 2 sine theta times another sine theta. Okay? So dx d theta would be what? Okay, well, we can even distribute the cosine. Okay, and I can actually rewrite this as cosine theta plus sine 2 theta. Since I remember the identity, I'll make my life easier instead of using product rule. I can just use chain rule. Okay, so dx d theta would be negative sine theta plus 2 cosine 2 theta. Okay, so that's dx d theta. How about dy d theta? That would be, well, again, if I distribute this out first, it'll be sine theta plus 2 sine squared theta. So let me just write it like that. Dy d theta would be cosine theta. Okay, derivative of this guy would be, we need chain rule, so it'll be 4 sine theta cosine theta. Okay, let's hope I did that right. So now we just plug into here. Dy theta, d theta is cosine theta plus 4 sine theta cosine theta. Divide by dx d theta, which is minus sine theta plus 2 cosine 2 theta. We evaluate this at theta is 0. That's what we want the slope of tangent line at. Theta is 0. So what do we get? We get, well, when theta is 0, sine of 0 is 0. So this whole term would go away, similar to here. Okay. So we get cosine is 0, which is 1. 2 cosine of 0, which is, cosine of 0 is 1, so 1 over 2. Slope of the tangent line, half. Okay. All right, we're almost at the end. This is the second to last problem, I believe. For what values of p will this series and this series converge? Okay. This one you should recognize as one of the p series. This one is a geometric series. For a p series to converge, the power 2p has to be greater than 1. So p has to be greater than half. That one's easy. For this guy, remember a geometric series, the absolute value of the common ratio, so in this case p over 2, has to be less than 1. The absolute value is critical, okay? Not just p over 2 has to be less than 1, okay? So how do we solve this inequality? Well, absolute value of p has to be less than 2. Okay, so p has to be less than 2, but greater than negative 2. Okay, so in this particular case, if you didn't have this condition, it would still happen okay. But this is the most general solution for this guy to converge. P has to be between negative 2 and 2. Okay, so both of these conditions have to be met. Okay, p has to be greater than half, so anything for p less than half would not work. There are some values of p that are less than half that works for this geometric series, but not for the p series. So it has to be p is greater than half and p less than 2, because this p greater than half dominates this p greater than negative 2. Okay, so this has to be true, or we can write it as half less than p less than 2. That is C. Okay, so we solved that one, and the last one over here. Let g be continuously differentiable with g1 is 6, g of 1 is 6, g prime of 1 is 3. What's this limit? Okay, when we plug in x as 1, we get integral from 1 to 1, which is 0. How about the bottom? We get g of 1 minus 6, so that's 6 minus 6, which is 0, so 0 over 0. Indeterminate, we can use L'Hopital's rule. So limit x approaches 1. What happens when we differentiate the top? What do we get? We get g of x by fundamental theorem of calculus. The bottom, we get g prime of x. We just differentiate g, which is g prime, derivative of 6 is 0. Okay, so this is just, now we plug in x as 1, g of 1 over g prime of 1. What's g of 1? That's 6. G prime of 1 is 3. The answer is 2. So D. Okay, that's it for the no calculated portion. Hopefully you found this helpful. Please like this video if you did. And if you haven't already, also please subscribe to support the channel and also to get notified for the next video that will come out, which will probably be me solving the calculator required portion part of the 2012 BC exam, right? So I'll see you in that video.